After encryption, decryption, and encoding, decoding, let's go toward the third branch of cryptography, which is hashing. So hashing is the process where we convert any amount of input into a fixed size of output, and that output will be universally unique for that particular input. If we change a single binary bit in the input, the output will be changed, right? So it will always remains the same for the same input, right? And the output will always remains in the same size as well, and the output size will completely depends on the size of the algorithm or the algorithm which is defined, right, that we are using. So hashing, we simply create a universal unique string. It could be a readable string, it could be a non-readable string as well, but it has some pair of bytes. For example, if you take, let's say, if we talk about SHA-256, that's a common algorithm which is widely used, or you can talk about 512 as well. Here the SHA stands for secure hashing algorithm, right? So after SHA-512, let's say, the output for this SHA-512 will always be 512 binary bits, right? So the output of the size will always depends on the algorithm that you are using. You can take any size of input, right? And for the same input, you will always get the same output. That's the first thing about the hashing algorithm. So there are few characteristics of a hashing algo. Let's talk about the SHA, or we can take it any algo about that. So let's talk about those characteristics of the hashing algo. But the hashing, we simply create a universally unique string out of the input. So for hashing algorithm and for the hash, the output is usually called the hash, and for hashing algo, they are one way. It means you cannot reverse them, like encryption, decryption, and encoding, decoding. When you create the hash of the input, you cannot derive the input back from the hash. It's only a one-way function, right? So that's a one-way thing. Second thing, they always showcase the avalanche effect. So avalanche effect means if you change a single binary bit, it means minor change in input will show drastic change in output, right? If you change a single binary bit in the input, your output will be completely changed, right? That's we call the avalanche effect. The third thing is the collision resistance. Collision resistance means you cannot derive the same output, you cannot derive the same output for different input, right? The output will be universally unique. You will never ever get the same output for two different input strings, even if you check it for a single binary bit, even if you check it for a tons of gigabyte of data, right? You will always get a universally unique string. If you want to check it, let's say I'll check it here. Suppose this is the platform, you can directly go on the Google and check for online hashing algorithm. I have opened this first web page, and if we want to check the algo, for example, let's say I'm using SHA-256, right? If you want to use 512, you can go for 512 as well. So let's say we are using 512, and if I'm writing my name, the output size is 512 binary bits. Now it's again encoding into the hex. If you want, you can encode it into the base 64 as well, but if you want to decode it like we tried before, base 64 decode, you may get some non-readable characters, right? As you can see here, we cannot read these arrows, and there are few other non-readable characters as well, right? These characters are usually called as Mojibaki characters or non-readable characters, but you can encode the output into hex or base 64 into any other character set as well. It again depends on you. Now the simple change is, let's say if I change this h to any other character like A, B, C, X, Y, Z. For example, if I show you, let's say I'm using ask UTF-8 here, right? UTF-8 table. And we know that initial 128 characters are same for ASCII and the UTF-8, right? So I'm using the character A, and the decimal value for this one is 41. And if we go for the 42, there is a single binary bit change, right? You just simply change a single binary bit in that. And if you want to check this, like if I type a simple A, this was the output, and if I replace it with the B, you can see the output is completely changed, right? So that's what we call the avalanche effect. If you change a single binary bit in the input, you will completely change the output. That's what we call the avalanche effect. Now, hashing algos are widely used for the integrity of the data. For example, if you have some data, let's say when we made some kind of transactions, for example, let's say you are trying to purchase a PS5, right? You are trying to purchase it on Amazon. So here we have Amazon, and Amazon have, let's say, integrated with PayPal, right? So what Amazon will, you're directly interacting with the Amazon will give you the URL where you can pay through the PayPal. Now you will be redirected to the PayPal portal, and on the PayPal portal you will make the transaction. Now the response from the PayPal, you will send it to the Amazon. You will get the response from PayPal, and you will send it to the Amazon that I have successfully done the payment, and this is the payment receipt or payment confirmation, right? Now for example, let's say you have made the payment, you get the status code as success, right? But if you don't make the payment, you will get status code something like false, success, or let's say failure, right? If you are an attacker here, if you behave like an attacker here, you can simply modify this failure into success with help of proxy softwares like Burpsuite, Hostify. You can use multiple tools out of there. You can also use your Postman as well. It depends what tools you want to use, but Burp is one of the common tool that we generally use for real-time request modifications, right? So being an attacker, you can change the status code from failure to success, right? Now if you send this success code to Amazon will think that you have made the payment, you have completed the order transaction, and it will complete the order, right? But in that case, Amazon will face a loss because you have not made the payment, but you convince the Amazon server that you have done the payment, right? To avoid this kind of parameter tampering, parameter modification, where you can change it from failure to success, to avoid these things, they implement the hashing algorithms, right? So they can identify that you have changed the parameter or not. Whenever PayPal will send you the response, in that response they will always send you the HMAC or the hash value. They can send you the HMAC or they can send you the hash value. These are two different things, but either one of them will always be there whenever they send you the response or the payment status response, right? If we talk about the HMAC specifically, HMAC is used to authenticate as well. Like we can derive a unique value. For example, let's say if we talk about the Amazon example here, like we have a JSON response in this one. We got order ID, and for order ID we have, let's say, 1 2 3 4, and like this one, this is our order ID. After that, for, let's say, let me just structure this as well. After this we got like payment amount, or let's say a amount kar lete hain. We got the amount, and let's say amount is something like 50,000. After that we can take it as status. I'm just taking a simple example, so you can just take it as failure, right? This will be the hash that PayPal will send you within the response. Now, if you want to change this one to success, right, you need these two values, right? Because the hash will be created out of these two values, right? You will use these two values to create the hash, and then the new hash you have to paste here and send the value to the Amazon server, so server can validate again. That's how it generally works, right? But if we have implemented the HMAC, right, for HMAC you need a specific key like encryption decryption, and you can create the hash value only if you have the key, right? For example, let's say Amazon server and PayPal, they negotiate that we're gonna use this value Siddharth Sangwan as a key, as an identifier that you are an authentic person or not, right? And because this key is only known to Amazon and PayPal server, you cannot derive the right hash value out of the data, which simply prevents the attacker from modifying the data, from modifying the parameters in the request or response, anything, right? So that's how they generally implement and generally validate that the data is being tampered, being modified or not. There are multiple algorithms which you can use for hashing, and these are just few of them. Like you can use MD. There are multiple versions of MD like MD2, 4, 5. 2 and 4 are not widely used. There are SHA 1, 2, 3. SHA 3 is the latest that is widely used nowadays. You can also go for KEK, you can also go for Shake, KMAC. There are multiple options that you can go for, right? And there are some encoding options as well. So you can pick any one of these hashing algorithm that you like, but they are mainly used to validate that the data is modified or not. That's all.